You type a prompt, a cursor blinks, and text flows onto the screen. The machine replies instantly, with an answer that feels thoughtful and precise. Over 20 minutes, you refine the parameters. The machine answers your follow-ups, correcting its tone and adjusting to the constraints of your specific project. It mimics the cadence of an entity building up a working understanding of your needs. But an hour into the exchange, the rhythm breaks. You ask a highly specific question, and the machine responds by entirely ignoring a foundational rule you established in the very first prompt. The system hasn't tired out, and it hasn't suffered a sudden glitch. The breakdown happens because we misunderstand what this conversation actually is. There is no continuous AI listening on the other side of the screen. Between your messages, the model possesses absolutely no persistent memory of your exchange. What is actually happening is a mechanism called transcript resending. Every single time you press send, the entire conversation history up to that exact point is packaged up and resent to the model fresh. Every confusing behavior you experience in a long conversation traces back to this single architectural fact. The moment the model finishes generating a response, its work is completely over. It retains absolutely nothing. There is no internal state being updated and no working memory waiting for your next input. Looking at the system documentation, the text states clearly, the model has no state between calls. The continuity you feel is a parlor trick performed by the software wrapped around the model, which holds on to the text log on the AI's behalf. From the machine's perspective, it is waking up for the very first time, armed only with the text file forced in front of it at the exact millisecond you press send. On turn 1, you send a single paragraph, roughly 1,000 tokens, into the processing unit, a distinct task. By turn 5, the system bundles your new message with previous exchanges. The data packet expands fivefold, pushed into the exact same unit. Because these models operate on token-based pricing, the financial cost compounds with every exchange. By turn 50, you are paying to resend the previous 49 turns over and over again. This also explains the physical slowdown you experience. The machine takes longer to start generating an answer because the volume of text it is required to read is continuously multiplying. These long interactions function as a series of isolated, one-shot calls, with each turn carrying a heavier burden of historical baggage. Reach turn 20, and the transcript you are sending has ballooned to tens of thousands of words. The model processes massive input unevenly. Architectural attention heavily weights initial instructions at the top and recent messages at the bottom, while the middle fades out of focus. Any critical reference dropped in this middle section gets completely drowned out by the brightly lit edges. The AI hasn't technically lost your data. The information is still in the transcript, sitting exactly where you left it, but it is buried in a structural blind spot the machine naturally ignores. Eventually, this growing text file hits the context window. This is a strict, unchangeable mathematical limit on the total input the model can process in a single call. As the system documentation shows, developers build workarounds to delay this limit. Systems will often silently truncate older messages, or summarize older parts and replace the full text with the summary, compressing your history to save space. This mechanism is why you cannot train a conversational model by repeatedly scolding it or stating your preferences over a long thread. You are just adding temporary instructions to a text file that will soon hit its budget limit. No matter the clever engineering masking it, the appearance of an infinite relationship inevitably shatters against the hard ceiling of the context window. For complex, substantive work, the optimal strategy is to abandon long threads entirely. You will get better, faster results by starting fresh, focused conversations using tightly written summary prompts. When you do need to supply vital instructions, respect the rule of placement. Put crucial context at the very start of your framing, or explicitly restate it at the very end of your prompt. Behind the chat interface, there is no shared history. There is only a function executing a command, waking up to read the script of a past it never lived. Working effectively with these models requires accepting that the machine has no memory of what came before.